President Biden has introduced the first image to be shown publicly from the James Webb Telescope.
For decades, the search for other worlds, truly alien planets beyond our solar system, has been an endeavor of imagination and indirect observation. We saw hints in the way stars wobbled or dimmed, indirect evidence pointing to massive orbs tugging with unseen gravity or casting shadows as they passed. The James Webb Space Telescope, launched in late 2021, changed everything. And now, for the first time, it has done what astronomers only dreamed about: captured a direct image of another world orbiting a distant star. Not a shadow, not a signature, not a trace. A real image. Clear, confirmed, inarguable. This historic milestone redefines how humanity understands its place in the cosmos. Before we start, hit the like and subscribe buttons for more exclusive news. The planet, officially named HIP 65426b, was first discovered in 2017 using the European Southern Observatory's Very Large Telescope in Chile. Back then, even the most advanced instruments could only spot it through coronagraphy, a method that blocks out a star's bright glare to expose faint objects nearby. What they found was stunning. A massive gas giant, several times the size of Jupiter, orbiting its host star far enough away to allow instruments to make detailed observations. But it was not until James Webb turned its gaze upon HIP 65426b that the world was truly seen. Captured in several wavelengths of infrared light, the planet appeared as a real object, its shape, atmosphere, and size illuminated with breathtaking clarity. This image is more than a photograph, it's a revelation. James Webb's powerful infrared instruments allowed scientists to cut through the noise of starlight and cosmic dust, delivering an image so detailed that it could isolate the planet's glow from its parent star, a feat that previously eluded every telescope in operation. The result was a luminous orb striking in its alien beauty, radiating heat from its formation. The data that accompanied the image revealed layers of atmosphere, clues about composition, and even temperature readings, all of which painted a portrait of a planet that has never known the warmth of our sun, but burns hot from within. The significance of this accomplishment cannot be overstated. This is the first time in history that humanity has laid eyes on a fully verified image of a planet outside the solar system. Not an artist's impression, not an inference, but the actual light of another world captured by a human-made instrument. It redefines what is possible in planetary science. For years, exoplanet discovery relied heavily on indirect evidence, most commonly through the transit method, where a planet's passage dims a star's light slightly, or via the Doppler method, observing subtle shifts in a star's motion. These methods told us that exoplanets were common, likely even outnumbering the stars themselves. But they couldn't show us what these planets looked like. Now that barrier has been broken. With Webb's successful image, the gateway to observing planetary systems in all their variety has been thrown wide open. Scientists now have the unprecedented ability to look with their own eyes into the depths of a foreign solar system. This capacity opens a new era of discovery. The ability to image planets directly, without relying entirely on models and inference, means atmospheres can be studied in far greater detail. Clouds, weather systems, storms, composition, and heat distribution can all be parsed from the captured light. Even more profoundly, we now have a tool that can analyze whether those atmospheres carry the markers of life. HIP 65426b is a massive gas giant, inhospitable, likely turbulent, and utterly alien in every sense. But the very fact that it could be seen and imaged by James Webb is a signal of what is to come. It is easier, astronomically speaking, to image a planet that is far from its host star and large in size. That made HIP 65426b a relatively easy target compared to smaller, rocky Earth-like worlds orbiting closer to their suns. But Webb's instruments are not limited to the massive and the distant. As calibration and targeting methods improve, the telescope could soon focus on smaller exoplanets, those that lie in the habitable zones of their stars where liquid water could exist. Imagine, then, the first real image of an Earth-like planet cloud-dappled in blue light years away. What we see now is the first rung of a much taller ladder. The capture of HIP 65426b is not just an engineering triumph. It is a moment of cultural and philosophical awakening. Humanity has long looked to the stars and imagined other worlds. Ancient peoples saw gods and monsters in the night sky. using their stories to give meaning to the darkness. Centuries later, telescopes showed us moons, rings, and the swirling atmospheres of our solar system. Now we are finally looking outward and seeing, not imagining, not inferring, but witnessing other planetary bodies in real time. This image validates generations of inquiry and advances a legacy that stretches from Galileo to Hubble to Webb. The technology behind this moment is itself a marvel. James Webb's near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, are capable of collecting light from objects billions of light-years away and resolving details as fine as the composition of planetary atmospheres. When pointed toward HIP 65426b, these instruments worked in harmony to block the light of the parent star using special coronagraphs, while isolating the faint infrared signal of the planet. Each wavelength brought new details. In some, the planet appeared brighter, showing thermal emissions. In others, it was fainter, suggesting the scattering effects of atmospheric components. Combined, the data formed a visual and spectral fingerprint, a profile of a world never touched, never visited, but undeniably real. The implications stretch beyond astronomy. Fields like planetary science, atmospheric chemistry, and even astrobiology are transformed by the ability to observe exoplanets directly. With continued observations, scientists may be able to identify water vapor, methane, carbon dioxide, and even the elusive signature of oxygen. Each molecule is a potential signpost pointing to conditions favorable to life. Though HIP 65426b is not a candidate for habitability, it proves the method works. The telescope is functioning at or beyond expectations, and the exoplanet imaging revolution has officially begun. Consider the scale of this achievement. The star HIP 65426 is roughly 385 light-years from Earth. That means the light captured in the image, the photons that bounced off or radiated from the planet, began their journey when Galileo's telescope was a novelty. And yet, here they are, transformed by a mirror in space the size of a tennis court, caught by superconducting sensors chilled to just a few degrees above absolute zero. This convergence of time, distance, and technology underscores the extraordinary nature of the moment. For the scientists involved, the image was a reward beyond expectation. Many had spent careers working on indirect detections, simulations, and models. To see the object itself, unmistakably, undeniably, was a validation of decades of effort. And for the public, the image offers something equally profound, a chance to feel connected to the larger universe. The bright dot in the Webb image may be distant and alien, but it is a part of our shared reality. We now know what it looks like when a planet orbits another star. This image also strengthens the roadmap for future missions, with Webb demonstrating that direct imaging is not only feasible but productive. Future space telescopes like the planned Nancy Grace Roman Space Telescope, and even more ambitious concepts like LUVOIR and HABEX gain momentum. These next-generation observatories could extend Webb's capabilities, imaging even fainter, smaller planets, and performing spectroscopic analysis in the search for life. The precedent is now set. As humanity stands at this new threshold, the ethical and philosophical questions begin to arise. If we can image planets, we can analyze them. If we can analyze them, we might detect signs of life. And if we detect life, we confront one of the oldest and most profound questions ever asked. Are we alone? The image of HIP 65426b is not the answer, but it is a glimpse through the doorway. It is a proof of concept that the tools now exist to find the answer in our lifetime. Even in its relative infancy, the James Webb Space Telescope is already altering the fundamental structure of knowledge. With its first image of an exoplanet, it has demonstrated a capability that will echo for decades. HIP 65426b may be one of many such images in the years to come, but it will always be the first. The first world beyond the solar system we have truly seen with our own eyes. Not guessed, not modeled, seen. There is a poetic symmetry in how Webb operates. By looking into the infrared, it looks at heat, not light. A kind of thermal vision that reveals the invisible. And in doing so, it uncovers not just celestial bodies, but our own desire to understand, to explore, to reach out across the void. Just as the first moon landing showed us the Earth from afar, this first exoplanet image shows us that there is more out there. Real places, real worlds, waiting to be discovered. They are no longer points of speculation, they are destinations. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us what are your thoughts on the James Webb image? Will it change space exploration forever? We want to hear from you. Thank you for watching and see you next time.